Well, today I am very pleased to be joined by Dr. Paula Carey, who is the Technical Director of Carbon8. This podcast is an interesting one for me because increasingly over the last few months, we are hearing from the industrials that we work with about more and more that they need to understand what the business model is around decarbonisation, not just what's possible in how they can decarbonise, but how they can do it sustainably. And I think Carbon8, and Paula, you can obviously tell us more, kind of that's exactly where you play into here. So can you give us a little bit, first of all, on your own background, but then just talk to us about Carbon8's approach in this space?
Right, hello, I'm Paula Carey. I'm the Technical Director, but also one of the founding directors of Carbon8 Systems. So I'm a geologist by training, and for most of my career I was an academic, or for 25 years I was an academic teaching geology, and my PhD is in tramping across the Scottish Highlands, mapping Precambrian rocks. So very much a change of direction, and it's been that sort of gradual change driven initially by trying to find funding for research. So I soon realised nobody was going to pay me to tramp across the Scottish Highlands, unfortunately. So I moved back into engineering geology, which had always been an interest of mine. And from then we set up a Centre for Contaminated Land Remediation at the university. And we were developing a particular technology for the treatment of contaminated land using cement. So we wrote guidance, the industrial guidance for the Environment Agency on cement stabilisation, but we were using carbon dioxide as an additional ingredient in that process because there were a lot of advantages of using carbon dioxide. So getting into the use of carbon dioxide was very much as an extra ingredient. And we were developing the technology both for soils and also for industrial residues. And it soon became apparent that the use of CO2 was a particular USP for the company. So that's how we got into the carbon capture and utilisation industry.
And when we first met back in January, and also in our recent call, we were both talking, I suppose, about this idea that the prevailing view of CO2, particularly in industry, is one of liability these days, and one of it's a waste, it's a problem. But of course, that's not the lens that you see it through. So talk to us a little bit about that.
Well, I think it's the scale of the problem, and I think it's really important at the outset to say that utilisation is not a magic bullet. It's not going to make it all sort itself out because we can use all this CO2. The volumes involved are such that utilisation is one tool, one solution in a range of solutions. We're going to have to use carbon capture and storage for most of heavy industry because of that scale. But most big problems you have to apply a range of different solutions to, and each one has different economics. And I think the economics of utilisation is where we've got to really drive home to industry that if you value the CO2, then you can employ a range of options. The cement industry is a very good example of that. I mean, cement industry is responsible for 7 or 8% of global CO2 emissions, and they're banding together and have developed a 6-point sort of roadmap of how they're going to reach net zero by 2050. Only one of those is actually carbon capture and storage. The others are small incremental ways in which they're going to achieve net zero, changing fuels. 2 of them are actually directly related to what Carbon8 Systems does. That's the use of old concrete construction and demolition waste as aggregates, so recycling waste materials basically. And the 6th point is carbonation, and using carbonation for a variety of applications within the cement and concrete industry.
So carbonation for those kind of out there who might be investors, they might be people in roles within industrials but are new to this whole area. Tell us, what does that mean? What in practical terms does that mean?
Well, carbonation is a really interesting method of using CO2 because First of all, it's a natural process. And there are quite a lot of research people exploiting that natural carbonation. There's a group at Oxford, for example, who are talking about a thing called enhanced weathering. So carbon dioxide in the atmosphere will react with rocks. So we come back to my geological background here. So it's quite a nice circle. If you leave many industrial residues, particularly thermal residues like residues from cement, steel slags, paper ashes, or ashes from energy from waste, if you leave them out in the atmosphere, eventually they will both carbonate and hydrate. And that carbonation process actually improves the properties of a lot of those residues. But it's an expensive thing if you're producing a residue and you've got to leave it out for 6 months to carbonate, because it takes up space, you have to manage it, they're hazardous in some cases, so you can't just leave them in the rain. What happens is that you've got calcium magnesium phases within those residues, and those react with the CO2 either in the atmosphere or, in our case, in a controlled environment, and produce calcium carbonate. Now, it's a very simple chemical reaction in principle. It's sort of GCSE level chemistry.
Well, that's fortunate, because that's where I ended up.
Yes, CaO plus CO2 gives calcium carbonate or limestone or calcite. And that reaction is one of the few reactions of CO2 that is energy efficient. So CO2 is quite a stable molecule. And to make it do exciting things like turn into fuels or plastics or other chemicals, you've got to put a lot of energy into it to break it. But as I've just said, carbonation is a natural process, and it's actually what's called an exothermic process. So it gives out energy. So you don't need to put energy into the system. You can benefit from the energy that you can get out of it. So it has a lot of advantages over the other utilisation technologies.
Okay. And then just to kind of, again, put that in a practical context. So where does, in the kind of value chain of cement to other products and other markets, where does carbonate play? What is it that you're doing with that, the end product of that process of carbonation?
Because we've always been in waste treatment, we've looked at the problem of waste and the disposal costs. So if you take a cement works as a byproduct, particularly now where they're moving towards using refuse-derived fuel. So in the past, they've used fossil fuels. So in an attempt to reduce their carbon footprint, they're using more and more waste-derived fuel. And that has knock-on consequences to the quality of the cement. So they actually have to introduce what's called a bypass into the cement works to take out some of the elements, particularly chlorides and sulfates, that are generated by burning the refuse. So they produce a residue that's known as cement bypass dust. And obviously that's going to increase as they burn more refuse-derived fuel. So what we do is take a residue that is a cost to them because they've got to dispose of it at the end. We take that residue and add value to it. So we save them the cost of disposal of the residue. We capture their CO2 in that residue, and then we make a product that can replace natural aggregate. So you're saving on the cost of the natural aggregate and also on the carbon footprint of that natural aggregate. So that's really our business model. And there are some issues around that to do with legislation in different countries.
That's useful context, I think, for maybe taking a step back for a moment and looking at this from a different angle. So as I said at the start, what's been interesting for us and for my team is this kind of slight shift over, particularly the last few months. There's been a change in perhaps how some of our industrials talk to us about the challenge of decarbonisation. It's no longer just about how can we do it, or are there technologies of scale, which seemed to dominate a lot of our conversations last year. There's definitely much more interest and growing interest and need for the business model around this, or the way to view CO2 or starting to view CO2 as an asset. Why do you think it's taken the corporate world so long and still taking so long for them to really understand that there is some value here? What's been the block, do you think?
I think it's the scale of the problem, and most of the utilisation technologies are not going to deal with the whole problem. And it's then capacity. I think we're at this watershed at the moment where technologies such as ours are actually now realistic. I mean, if you look around the investment market at the moment, there are a lot of VCs and CVCs actually now investing in these technologies. And there's some big monies going into similar companies to ours. You know, there's a real drive now, and I think there's a realization that we're not just people working in a laboratory, we can scale up.
What is it going to take, or what needs to happen for an industrial to change that mindset and sort of in practical strategy and planning terms start seeing CO2 as value?
I think it has to be stakeholder influence. So these big companies like the cement companies or the steel companies now have this internal value on the CO2. So it doesn't matter really whether there's an ETS scheme or a carbon tax or whatever, because the actual companies are saying to us, CO2 is a cost. And I think that change of mindset is what's happening at the moment.
Yeah, that neatly leads into, I guess, my next question, which is how, what impact does that understanding have on the planning and financing of projects? But you're already saying, well, because this kind of switch is changing of that the CO2 has value, we're setting an internal price against it. I guess that's how it affects the financial aspects of planning for this. Are you seeing in the way that industrials engage with you that it is also changing the type of projects or the type of discussions that they're coming to you with?
Well, most of our leads are incoming. I mean, I get emails and calls, well, 2 or 3 a week from companies saying, we've heard about you, how can we work with you? Which is a fantastic position to be in. There is still a financial driver though, unless you can show the companies that the business model works, they're still not, then on the whole, they're not going to say, yes, we'll have one of your plants. We have to show that to them it's a wealth generating operation, which, I mean, is fair enough. You know, that's a good position to be in, because we can in most cases show that there's a good business case for doing it.
Mm. And I know you mentioned before that the ability to sort of look at waste and disposal and repurposing and reutilization of a waste product is affected by legislation in different regions and markets. Are there certain markets which are just easier for you to engage with?
So yes, there are. The legislation across the world is so different, and the way wastes are managed. I mean, part of it is if you've got a big country with a low population, you are not so careful about what happens to your wastes, and you know, got lots of holes in the ground. Well, we'll put our waste in there without thinking of the value of the waste, and B, the longer term environmental consequences of that. So in Northern Europe in particular, landfill costs are really high. But then if you get into the detail, even across Europe, each state has a different implementation of the waste management legislation. So landfill costs vary across Europe. Then there aren't costs for waste management in India, or to a certain extent even in the US. So it's quite hard work to show that business case. You have to have the negative value of the residue before the business case will work.
And a slight change of tack with this question. Obviously, you're talking about, and you're embedded in this one area of utilization. What other forms of utilization are there? And you know, what are you seeing as the relative impact in terms of decarbonisation?
If you just look at the news and listen, one of the biggest things that people are talking about is making fuel. So both biofuels and fuels from CO2, so methanol and ethanol, and those sorts of, count them as sort of precursor chemicals, so you can go off into different routes. I mean, it's a real magic bullet to be able to say that my aircraft is running on fuel made from CO2. It's fantastic, isn't it? except that, of course, as soon as you burn that fuel again, the CO2 is back in the atmosphere. It's the same with a lot of the chemicals, not so much with the plastics. They're going to last a bit longer, but they are still non-permanent versions of use of CO2. So we need to think about them as perhaps storage of CO2. So you can make a lot of fuel and store the CO2 in that fuel and use it gradually. And of course, you're replacing the fossil fuels, so the net CO2 should be less. But to me, it's much more of an issue that it's not permanent capture. But certainly fuels and manufacture of all sorts of things. There's some really good work going on in catalysis and changing the CO2 molecule into other exciting products. So fuels, precursor chemicals, sort of plastics, and all sort of everyday products which have good value, and therefore to use the CO2 has value. The problem is that you need an awful lot of renewable energy to make those transitions happen. And the demand on renewable energy is enormous, and everybody's going to be driving around electric cars. Electricity is not carbon neutral. You've got to have it made by renewable means, and you've got to transport it, and you've got to make the things that you've got to make your turbines and things. So it's not as simple as just saying, oh, we can use CO2 to make these things. We really have to concentrate hard on the life cycle of these things. It's the same with recycling in general and the treatment of waste. It's not as simple as saying, oh, we've got all this plastic, we need to recycle it. You've got to think about the whole life cycle of that and how much energy you need to put into the plastic to recycle it, and what byproducts you get from that process.
Okay, so let's have a look at then. I know you've got a number of interesting projects underway, but the one I had picked on a little bit is Vicat, which is, I believe you're saying, I think you sort of told me it's just sort of yet to break ground. Is that right? We're sort of in the early stages of forming it.
Our containerized system at the Vicat plant has been there since probably August last year. The problems we had are mainly COVID related. I mean, at the moment we're itching to get down there. We're held up by the fact that cement works have annual shutdowns. We can't actually get out there to start work on it again. The cement industry is a big market for us because there's this increasing quantity of what's called bypass dust. It has to be extracted from the clinker or the cement before it goes out. And it is fundamentally cement with a few other contaminants in it. So it's disposed of to landfill on the whole at a cost. But because it's like cement, it's got those calcium salts in it, both calcium silicates and calcium oxide, which will react readily with CO2. So we have a very simple plant in 2 containers where we plug into the flue stack of the cement works, and we take a small bypass from the flue stack and take a small proportion of the flue gas, pass it through our process and strip the CO2 from it. And then the remaining amount of the remaining flue gas goes back into the flue stack. So we don't have any emissions ourselves. Everything is controlled within the flue stack of the cement works. But we mix the cement bypass dust with the CO2 and produce a aggregate with it. So rounded 10 millimeter diameter pellets that can then be used in concrete, basically. So it replaces natural aggregate. So we're solving the problem of the residue and manufacturing a product. Aggregates, one of these products that is, you can really call it low value, high volume. So if you make lots of it, you're still not impacting on the aggregate market very much. So it's quite a useful market to play in. But of course, the aggregate has embodied carbon in it. So it's a low carbon product. And in the case of the cement industry, you could probably say it's a carbon negative product. So there's more carbon dioxide locked up in it than is used to make it. So when you then put it into construction materials, you then have either carbon negative or very low carbon building materials.
And in this particular project at the moment, you mentioned that obviously you're just taking a proportion of the flue gas and treating it. What sort of scale is that, and what's the kind of what do you anticipate kind of timeline to being able to do something bigger scale there?
It's always going to be controlled by the amount of residue. So it's a relatively small amount. The plant is capable of treating 12,000 tonnes of bypass dust a year, which matches the amount that's generated by the cement work. So we're going to be capturing about a third of that by weight, or between 25 and 30% by weight of that in terms of CO2. So, 3,000 tonnes of CO2 a year, which is a very small proportion of what's going up the chimney of the cement works. But the whole point is that it's there now and we're doing it, and it's going to be making money. Our business model means it pays for itself really within, we aim to have a payback within 2 years of the capital expenses. So, there's no reason why somebody shouldn't do it. And they're capturing some of the CO2 and also having the other carbon benefits of not disposing of stuff to landfill and replacing natural aggregate. So with companies like Vicat Cement Group, which is the big French cement company, they have several sites around France and internationally. So we like to think of it as a land and expand principle. So yes, at an individual site, we're not going to be capturing a huge amount, but we can roll it out very quickly. So as soon as we get the go-ahead from this plant, there might be 5 or 6 others in France that we can roll it out to very quickly. Takes 3 months to build our plant, a month to install it and get it running. So, it's here and now, and they can start making money out of it.
I feel like you're taking a very British approach to selling the benefit of what you're doing, because I hear what you're saying. You're not trying to claim this is the magic bullet that ends all CO2 problems, but the point is, this is one of the few options on the table at the moment for serious short-term gain. And from what you're saying, that the turnaround time, the return on investment time is quite different from many of the other short to medium term options.
The nice thing about our technology is it's actually complementary to some of the other utilisation technologies that are out there in the carbonation world. A lot of people would have heard of Carbon Cure and possibly Solidia cement. So Carbon Cure are putting CO2 into concrete as it's being delivered to site. So there's no reason why their concrete couldn't have our aggregate in it. So it would improve the carbon credentials of the concrete. Similarly, we could use Solidia cement in our process. So it's nice that they're complementary, and we hope that that's what's going to happen in the future as well.
And then in terms of regions and where you're deployed at the moment, what's the landscape? Where do you have pins in the map?
A lot of our activity is in Europe, but when you're talking to people like cement companies, it's international. So our first demonstration of the containerized system was in Ontario. So we have interest in carrying on in Canada. We're talking to people in the States. We're talking to people in Australia, Asia, India, but principally our activity is in Europe. I mean, at the moment, it's hard enough to get to Europe. So when we do have some, we already have 3 plants operating under license in the UK. So these have been commercial since 2012. So the first plant was commissioned in 2012, and the third was commissioned at the beginning of 2017, I think, or somewhere around there. My colleagues from Carbon8 Systems back in 2010 formed a new company that was then called Carbon8 Aggregates, where the three of us commercialized the technology for the treatment of air pollution control residues, which are from energy from waste. And two of the plants were built up until 2016. Then the three founding directors of Carbon8 Aggregates left the business to take the technology more international and look at different waste streams. So we left Carbon8 Aggregates to get on with it in the UK. And as I said, there are three plants now processing in excess of 40,000 tonnes each of the technology. So although they use bottled CO2, it comes to them in a tanker. It's pure CO2, mostly collected from fertilizer factories and things like that. So it's a waste CO2, but it's been purified and refined so that it can be liquefied and transported in a tanker. So the breakthrough for Carbon8 systems was really moving to flue gas capture direct, rather than if you buy CO2 in a tanker, it costs you £90 a tonne. And you're also affected by shortages of CO2. People always get amused when I say, well, yes, if you recall during the World Cup in the UK, there was a shortage of CO2. Everybody complained they weren't going to get their beer. Because if you have a breakdown or a maintenance period for fertilizer factories, the CO2 market is really difficult. So there's a real incentive to use flue gas derived CO2.
And I know you've mentioned that it's not just cement. Cement has been your kind of the main sectors of interest, but where as you kind of look forward for Carbon8, what sectors and geographies and other plans do you have?
Well, the nice thing, a lot of what we do is to do with what they call the foundation industries. So cement, steel, energy from waste, it's not quite in the foundation industries, but it's that sort of scale. Also paper, even though we think that paper is a dying breed of material, actually paper is still used quite a lot. So the paper industry produces a very nice residue that we're looking at. We can also go back to our roots and treat residues that are difficult to handle, and go back to the idea that you can carbonate thermal residues and mix them with other hazardous residues. So you can then start to talk about waste treatment sludges and contaminated soils and a whole range of things like that. We've got quite a big pipeline of contacts in those various areas. We're also busy looking at other products. So as I said earlier, aggregate is a low value, high volume material. So we can do two things. We can make the value of the aggregate go up. So if you make your material lighter and more carbon negative, then its value should increase. Or we can start to think about other more exciting products with carbonation. So what else can you make in the carbonation process? So that's the other area that we wanted to develop. So at the moment we are looking for investment, and a large proportion of that investment is to develop our R&D.
Well, that is probably a good place to wrap. Really useful. Thank you so much, Paula, for joining us. And good to hear not just about obviously what Carbon8's doing, which is fascinating, but really useful to hear your thoughts, I think, on development of that as a market, and the different forms of utilisation that we can be looking to develop.
There is a lot that the governments can do to promote utilisation.
I think, this is a massive generalisation. It always seems to me that governments find it easier to think in terms of technology rather than business model, don't they? So that's the easy part for them to influence, the easy part for them to explain. But yes, would be interesting to see a lot more about how we actually incentivise and encourage marketplaces for these kind of products. Well, again, thank you, Paula.
Thank you.